Alright, hello everyone. So welcome to the final video of integration by parts video series. What are we going to do here? Well, in this video I'm going to address a very important problem that you guys have, which is how to choose the correct integration technique. How do I know that whether you have to use integration by parts or integration by substitution? Now, the criteria that I'm going to present you will not work for every problem, but it will help you to survive through most of the problems. Okay, so try to be with me until the end of the video. But I'm really confident that you can use this criteria to decide the technique more than 90% of the problems. Okay, alright, so let's get started. So I have a column for integration by substitution, integration by parts. Now I'm going to develop this criteria. Okay, so let me start with an example. Let's say you want to integrate x natural log x, or we'll say x sine x. Okay, alright, now what is the technique that we have to use? Since I wrote it in the second column, okay, we have to use integration by parts. Okay, so let's start with an example. Now, why do we need integration by parts to solve this integral? What is so special about this integral? Look at the function that you have to integrate. The key thing that you can take away is that x is an algebraic function, sine x is a trigonometric function. So this is a product of two different types of functions. Okay, so remember, when we use integration by parts, we use LIAT rule for the most of the problems, right? The idea behind LIAT rule is that you have two different type of functions as a product, and when you want to decide you use that LIAT rule. So in integration by parts problems, most of the time, you will have two different type of functions as a product. So that's a hint towards integration by parts. Okay, another example, x times e to the x. X is an algebraic function, e to the x is an exponential function, product of two type of functions. So look what you have to integrate, what type of functions they have given to you. Okay, all right, don't click out this video right now, okay, because I'm not finished with the criteria. That criteria will not work for every problem. Okay, let me give you another problem. Okay, so let me write it here. All right, now x e to the x square. What do you think? Now right away, if you use my criteria, this is a product of two different type of functions. Of course, this is an algebraic function, this is an exponential function. So integration by parts, right? No. Why is that? Okay, our criteria fails. Now, what is so different here? Now, obviously, this is integration by substitution because we have only two techniques. So let's put it here. Now, why is this problem we have to use integration by substitution? What is so different here? So the whole idea about integration by substitution is that you have an inside function, right? A composite function, a function inside another function. And not only that, that inside function's derivative should be also there somewhere else in the integral. So is that the case here? Okay, we have two different type of functions, but see, you have a function inside a function. So this inside part is x square and its derivative is 2x. Forget about 2. We have x somewhere else in the integral. So that's a major hint that this is integration by substitution, even though you have two different type of functions. Okay, all right, so now what is the criteria again? Look at what you have to integrate. If it is two different type of functions, see whether you have an inside function. If you have an inside function, be careful with using integration by parts. Think whether you have to use integration by substitution or not. But if you don't have an standout inside function, then probably it's integration by parts. Look at these two integrals. You don't have an inside function, right? It's just regular variable x everywhere, right? Okay, let's see more examples. All right, how about this integral, sine x natural log cosine x dx. Now obviously two different type of functions, right? Sine, trigonometric and logarithmic. But inside the logarithmic function you have a trigonometric function, and derivative of cosine is sine, right? Forget about the negative. So we have that inside function and its derivative relationship there in this integral. So this is integration by substitution. Okay, all right, let me throw you a hard one. Ln x over x. What do you think? Two different type of functions, right? Algebraic function and a logarithmic function. Now can you see a standout inside function? Well, you would say no, but here's something very important. Now here there's no inside function really. Well, there is, but let's not focus on that. But derivative of natural log x is 1 over x. So if you can use integration by parts here, integration by substitution here, it will be very easy because your u will be natural log x. So this is a exception, okay? But you should have in your mind that natural log x and 1 over x, they are connection. So this is a little bit exception, but this is what it is, okay? So this is integration by substitution, but the criteria works for the most of the problems. E to the x sine x, look at this. Two different type of functions, right? Exponential and trigonometric. Do you have an inside function and its derivative relationship? Absolutely no, right? This is integration by parts. Okay, so let's do more problems. I'm gonna come to very interesting problems, okay? How about this? E to the sine x cosine x. Now two different type of functions, exponential, trigonometric. Okay, but we have a standout inside function, sine x, right? Inside e you have sine. What is its derivative? Derivative of sine is cosine. So yes, we have that relationship. So this is not integration by parts, this is integration by substitution, right? Okay, so now when I compare these two techniques, always I had two different type of functions. How about this then? Okay, now here, well, you have the same type of functions, x cube and square root 1 plus x square. You can think both of them as algebraic functions. Now which technique? Think about this one. Well, here we have that inside function. Do we have an inside function? Yes, we have an inside function, 1 plus x square. And its derivative is x, right? 2x. Well, forget about 2. Do we have x somewhere else in the integral? Well, we have more than x, right? So this is integration by substitution, but it will be a hard integration by substitution problem. Okay, we discussed these type of problems in my integration by substitution review series. Now, okay, I think let's do this example, x cube e to the x square. Same type of problem. So here actually two different types, algebraic and exponential. Now this is where I'm gonna end up this video. Okay, now this is two different types. Okay, so could be integration by parts, but if you look at this function, we have a standout inside function, x square. Now we have to check for its derivative. Its derivative is x, forget about 2. We have more than x, so it is integration by substitution, but a harder one. Here, this problem I think we discussed couple of videos ago, right? These are the type of integrals where you have to use integration by substitution and then use integration by parts again. Not again, then you have to use integration by parts. So remember that there are integrals that can be solved, that if you want to solve them, you have to use both techniques, okay? Integration by substitution and then integration by parts, okay? All right, keep that in mind. One more thing I wanna say before we get out of this video, since you're in integration by parts video series. Integration by parts, when you're doing integration by parts, you have to be very confident in LIAT rule. Make sure you know how to choose u exactly correctly based on LIAT rule. If you get a problem, okay, if you get a problem where you can use LIAT rule, okay, and once you use LIAT rule, if you are confused or if you're not sure, if you're not confident, or if you get something very complicated or when you use the integration by parts formula, do not switch your choices of u and dv. That's the last thing you want to do. No, do not switch u and dv. Make sure, make sure you use LIAT rule correctly. That is why I said you have to be confident in LIAT rule. Anyway, don't switch u and dv unless you did the LIAT wrong. Okay, but if you did the LIAT correctly and you think that you end up with a complicated one, think what's going on, look at the formula correctly. Okay, maybe you have to do integration by parts several times again and again. Maybe it's a never ending loop. Maybe you have to use integration by substitution. So think carefully what you get in the formula. Okay, so the formula is going to be uv minus vdu. If you are confused, definitely you are confused about this part. Okay, and do not switch u and dv. If you think that this is complicated, pause and think hard. Think whether you have to use integration by parts again or not. Okay, think about LIAT rule again for this new integral. Think whether you have an inside function or something like that. Think whether it's going to be a never ending loop or not. Okay, so especially you should rewatch my previous 2 videos again and again to get comfortable with that. Okay, so I present you a criteria that can help you towards most of the problems. What is the criteria? Look at the type of functions that are given to integrate. If you have 2 different type of functions, don't jump into the conclusion that it's integration by parts right away. See whether there is an standout inside function or not. If there is a standout inside function, check whether its derivative exists somewhere else in the integral or not. If so, then it's integration by substitution. If not, even you have an inside function, could be integration by parts. Okay, if you don't have an inside function, then of course choose integration by parts. Okay, but just be careful. All right, okay, so that's what I have for this integration by parts review series, and then I'm going to do trigonometric integration video series. So hopefully I will see you all in the trigonometric integration review series. Okay, thank you very much for watching this video. Bye bye.